Hello everyone, welcome back to our channel. So today we are going to solve this Leetcode question number 121, which says best time to buy and sell stock. Let's quickly go through the description and the problem statement that is given, and then we'll jump on to the examples for understanding the problem, and then we'll write an algorithm and solve this particular question. So the problem statement says that we are given an array of prices where the price at particular index is depicted by the ith index of that day. So the price given at particular index is the price for that particular day, and we can buy a stock on any of those days. We can buy a stock on any single day, but for selling the stock we should be selling the stock on the future date. So the condition here is, let's say like we buy a stock at index 1, then we can sell that stock on the future indexes, but not on the same index and not on the previous indexes. So if you buy a stock on day 1, then you can sell the stock on next days, 2, 3, 4, either of the days, but you cannot sell the stock on the same day or on the previous days. So we have to calculate the maximum profit and we have to return the result. There would be only one transaction of buying the stock and selling the stock. So we have to evaluate what is the maximum profit that we can achieve from this one particular transaction, and if no profit can be achieved, then we have to return 0. Let's quickly jump on to the example that is given to us. So the array that is given to us is 7, 1, 5, 3, 6 and 4. So this is the example that is given. So over here we can see if we buy the stock on day 2 and we sell the stock on 3, 4, 5 on day 5, the profit that we would be getting is 6 minus 1, which is equal to 5, which is the maximum profit that we can achieve over here. And then going on to the next example which is given to us, which is 7, 6, 4, 3 and 1. So over here, if we see, this is kind of an array with descending order. So if we try to buy and sell stock on any of the days, we won't be getting the profit, because let's say like if we buy the stock on with price 6 and we sell the stock with price 4, but eventually 4 minus 6 would be minus 2. So likewise, since it is in descending order, we won't be able to maximize the profit. So the result for this particular problem or this particular example would be 0. So if you see, eventually like what we are doing is we are finding what is the minimum element present till the array that we have traversed, and then we would be marking that minimum element, and after traversing forward we would be seeing like what is the maximum element that we see in the next subsequent array elements. So over here, if we see, 1 is the minimum and then 6 is the maximum. So here the answer would be 6 minus 1, which is equal to 5. So we have to keep a track of the minimum element that we are traversing, and we have to go through the rest of the elements next to the minimum, and we would be evaluating like what is the maximum difference that we are getting. So if we see the algorithm for this problem, so what we are going to do is we are going to traverse the array from 1 to the length, and then what we are going to do is at every particular index, So at any particular index that we are traversing, we are going to calculate three things. First of all, the difference between the current element and current minimum. So we would be calculating the difference between the current element and the current minimum that we have. And then what we are going to do is we are going to calculate the result. So the result would be, so the maximum profit that we would be calculating. So RES stands for maximum profit. That would be the max of the current maximum profit and the difference, the current difference that we are getting. And then we would also be calculating the minimum. So the minimum element we would be tracking would be the minimum of the current minimum and the current index element of the array that we have. So like this, so this is the algorithm overall. We would be traversing from first element to the length of the element, and then we would be calculating the difference first. The difference would be when we are selling one particular stock and when we are when we have bought that particular stock. So current element is for selling and the current minimum is for buying when we have bought that particular stock. And then if we see that the current difference is greater than the result or the maximum profit that we have, then we are going to update that maximum profit. And likewise for the minimum element, we would be tracking the minimum between the current index element and the minimum element that we have till now. Let's give a dry run for this algorithm for better understanding, and then we'll jump onto the solution. So the array that we are given is 7 1 5 3 6 4. So we would be traversing from index 1. At index 1 we have the element 1, and before going into this particular loop where we are traversing, what we are going to do is we are going to initialize the result, which is the maximum profit that we are going to return, as 0, and also the minimum element we would be initializing as array of 0, which would be 7. So these are the two variables that we would be playing around. The result would be storing the maximum profit, and the minimum would be storing the minimum till the array that we have traversed. So we would be starting from index 1. From index 1 we have the element 1, and what we are going to do is we are going to calculate the difference. We are going to see if the current difference is greater than the existing maximum profit that we have calculated, and we are also going to calculate the minimum between the current index and the current minimum. So let's quickly see the difference on this particular element would be 1, which is the current index, minus the minimum as of now is 7, which evaluates to minus 6, right? And then we are going to see the result. So result would be the max of 0 minus 6, which is equal to 0. And then we are going to calculate the minimum between minimum of 1 and 7, which would evaluate to 1. So now we have the maximum profit at this particular step as 0, and the minimum is now initialized to 1, updated to 1. Now let's jump on to the next element. So 5 is the next element. Let's see what is the difference. difference would be 5 minus 1, which is equal to 4. Now update the result. Result would be the maximum of 4 and 0. So the result here would be updating to 4, and the minimum at this particular step would be the minimum of current element. Minimum of current element is 5, and then minimum is 1. So the minimum is going to stay 1. So now minimum is 1, and the maximum profit that we have achieved till this step is 4. Now let's see the next element. Next element is 3. We calculate the difference, which would be 3 minus 1 is equal to 2, and then result, let's see, it would be the max of 2 and the existing result, which is 4. So the result is not going to update, and the minimum is equal to minimum of 4 comma 2, which is also not going to update. So the minimum, sorry, over here the minimum would be 4. The minimum would be the current element. The current element is 3, and the current minimum is 1. So the minimum is going to remain the same. Now let's jump on to the next element, 6. Let's see the difference here. So the difference here is 6 minus 1. 1 is the minimum, which comes out to be 5. So now let's see the result. So the result would be the max of 5 and the existing max. So now here we are seeing that okay, result is greater than the current, so the difference is greater than the current maximum result that we have evaluated. And now we see the minimum would be the minimum of the current element 6 and the current minimum 1, which is 1. So at this particular step we are seeing that 5 is the maximum difference that we are getting till this part of the array. Now the next element is 4. Let's see the difference would be 4 minus 1, which is equal to 3, and then result would be staying the same. Result would be the maximum of current result, which is equal to 5, and the current difference, which is equal to 3, which evaluates to 5 itself. Result is not going to update, and the minimum would be the minimum of current minimum 1 and the current element 4. So the minimum is going to stay 1. Now we have traversed through all the elements in this particular array, and we are seeing the result. The desired result that we have got is 5, which how we got is by buying the stock on with price 1 and the selling the stock on price 6, which gives us the maximum result. So now let's jump on to writing the solution, and we'll see how we are doing there and how many test cases are passing. Let's quickly jump onto the solution. Now, okay, so we would be initializing two variables. Result would be storing our result, and then another variable which would be storing the min. As of now, we would be initializing the first element as the minimum element, and then we are going to traverse this array from index is equal to 1 till the length of the array. Now the three steps that we are going to do is we are going to calculate the difference. the difference would be the current element that we are traversing and the minimum element so far, and then we are going to see if the difference is greater than the current maximum profit. Then we are going to update the result based on that, and then we are going to evaluate the minimum also. We are going to see if minimum is also updating, which would be the prices, which would be the current element, prices at the index, and between the current minimum that we already have. Now after we have traversed all the elements, then we are going to return the result where we are storing the maximum profit that we have achieved. Now let's quickly run this solution. Okay, both the test cases are passing, and then submit this. Okay, now we see like all the test cases have passed and runtime is also 3 milliseconds.